Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
All right, we're going to get a little bit deeper here in our mid-latitude storm intensification. There are 4 factors that we want to talk about in this little video about mid-latitude storm intensification. Those guys are going to be advection, lift, vorticity, and then the one other one that we're going to need to bring in that jet stream. The jet stream is going to be coming back for us a little bit, but that's going to be upper atmospheric venting. Right? Because as the air goes up, it's got to go somewhere. All right, so let's talk a little bit about these mid-latitude storms. Well, in the mid-latitudes, we know that if we were looking at this on a map, even if we were going to be looking at, let's look at North America. Good. Oh, that's beautiful. North America. All right. We know up here in Canada, we're going to have very cold and dry air, and we're going to call that our continental polar air mass. And so that continental polar air mass is there. We know down here in the tropics or in the Gulf of Mexico, we're going to have very warm and humid air. Okay, so we're going to say that that is going to be maritime because it is humid and tropic. So we have our MT air mass. Now, they could, I put these little arrows, but not necessarily, right? It could just be the cold air's up there, the warm air's down here. Neither one of them are moving on either one. Okay, that's totally possible. But in order to see these storms, we need to have advection. Oh, that's not dark enough. Advection. And that advection means that we're going to need the air to be moving back and forth. Okay, now we do have over here a pretty significant mountain range. Okay. Yeah, in California, we're going to have our Sierra Nevadas, but there's going to be another one that goes all up and down the entire continent, and that's going to be the Rockies. Okay, the weather that we see over here on the eastern side of the Rockies versus what we see over here are going to be very, very different. And that is because we have our ocean influence over here. Okay, that ocean influence is going to be affecting the humidity and the temperature of the air that we see over here. Over here, we're talking bitter cold and stone dry air. Very, very dry. Okay, well, it's not quite stone dry. It's got a little humidity, but not much. Cold and dry and warm and humid. Over here, we're going to have what's called maritime polar air, MP. So it's going to be humid, but cold, sure. And so we're going to have a little bit of movement down here. Down here, it's going to be maybe maritime, maybe tropic, but not huge tropic. Our air down here, let's just do San Diego versus the Gulf of Mexico. The humidity over here is much, much greater. So the more severe storms we see over here on the eastern side of the Rockies. Over here in California, we've got some nice weather. Right? We do see our thunderstorms from time to time, all sorts of good stuff like that, but the real action is happening over here. Okay, the advection, continental polar air, starts to get pushy a little bit, and the maritime tropic air starts to get pushy a little bit. Okay, when they start to get pushy, this is going to be our advection. The next thing we're going to start to see is some lift. Okay? And this goes back to a principle that we've been talking a lot about. If we have our continental polar air, that stuff is cold and dry. And because it's cold, the molecule's not moving very much. It's going to be very dense. Okay? So it comes through like a dense bulldozer, and this poor little maritime tropic air is going to be humid. Sure. And it's going to be warm. And it's going to be kind of wimpy. Okay, maybe wimpy isn't the nice term because, it does have the humidity, but it is not as dense. It's less dense. We'll just say that. Less dense. Okay, so here's this wall between the two. What happens is one of two things. You could have the cold air on the move. Bum, 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 bum. Okay, we symbolize that on the map. You might remember the jagged little teeth. And when that's happening, we call this a cold front. And when that happens, all of this maritime tropic air, boom, gets forced up, okay? So we get lift. Now, when we have a cold front, it is very rapid lift. And this is going to form our cumulonimbus clouds. These are going to be our more exciting clouds, if you will. Okay, that's the side of the cold front. However, we still could get other types of lift, even if it's just that warm air that's pushing. So let's draw this all over again. We'll draw our line going across. We'll do our continental polar air, and we'll do our maritime tropic air. Maybe that maritime tropic air is the one that's getting a little pushy, right? Maybe we're getting a little advection there. It's not going to be pushing through this continental polar. Okay, what it's going to start to do is just kind of go up and over. And so we're going to symbolize that with these like little curved lines, a red line with little curves. And so it's going to slowly, gradually go up that sort of ramp, if you will, of cold air. This stuff is dense and it's not moving. Okay, but we're still going to be getting a slower lift. Okay, from this, we're going to see our stratus clouds. Eventually, if everything works the way that we want it to, we'll see our nimbostratus clouds come out of this guy. So we're going to have our lift. Usually, it's going to be frontal lifting. Okay, and that's going to be part of that storm, right? So we've got our advection moving back and forth, and because of that, we get a little pushy, pushy, push, a little advection. All right, now, the next thing that we need to increase that storm intensity is going to be what's called vorticity. Okay, we see these guys in kind of one direction, right? We're looking at it from the side. We see the air going up. However, with a big enough group, what we're going to start to see is that air is going to be, we'll draw the side view, right? So the air is going to be forced upwards. But if we're looking at it from the top, if we're looking down on this, remember this is a low pressure system, and that air is rising and it's spinning in this counterclockwise rotation. And so what we're going to have along that front, right, is going to be this low pressure system. Okay? And that's going to start to cause some rotation due to Coriolis force. Okay, so rotation. We call that rotation vorticity. Rotation from Coriolis force, right? So we know that an object moving over the surface of the Earth in the different hemispheres, in the northern hemisphere rising, it's going to be a counterclockwise rotation. That's going to be that vorticity. Okay, cool. So let's just picture what's happening here. And I need another piece of paper. We'll grab this stuff here. Okay, so what's happening? Well, we've got the air, and we know that it is, let's just draw a cold front, continental polar, maritime tropic. We know that it's been pushed to the side, advection. We know that we're getting the lift there. Okay, because we're getting the lift, we're forming a lower pressure system right here. That low pressure system is here, and we know that the air is going to be coming in towards that low pressure system, and it's starting to get a little spin to it. And that's going to be our vorticity or our Coriolis force rotation. Okay, but now we have this air mass going up, and it's starting to spin good, but it's got to go somewhere. Right? It's gotta leave. And that's why this is one of the reasons why we're looking at that jet stream. Okay, the jet stream comes along, and if we were looking at it, what we would see is we'd see the jet stream as a big sort of river of air coming along. And I'm doing a little what's called a Rossby wave. It's a wave in that jet stream. The jet stream is going to kind of follow this same line between the cold air and the warm air. So the jet stream is kind of coming along. And what we need to picture is if it were a regular river, where are we starting to see the air going faster, or the water in this river going faster, going slower? What you're going to notice is that as we come down to this curve, if we were needing to even stay within these boundaries, the water is going to be kind of compressed in this curve, okay? And this is going to be where we see the greatest amount of water. But then, once we get out of the trough, okay, here's the trough. Remember, if we're looking at a wave, we've got a ridge and a trough, right? That trough, when we come out of that trough, it starts to diverge a little bit. That river gets a little bit wider. And what that enables to happen is it enables this air to not just go up, but to vent out. Okay? And so it's going to be able to continue to rise and to feed and to give that air someplace to go. Okay? This is one of the reasons that we care about that mid-latitude, the polar jet stream. The reason we care about this guy is because we want to know where it is, because it's going to be doing two things. It's allowing for venting, and it's also going to be kind of dragging this guy along. Okay, so it's not necessarily going to be going straight up. The center of the storm on the ground is going to be off a little bit. So it's going to be venting right here, but the storm is going to be down a little bit further. And it's going to be a little bit further to the west. And it's kind of dragging that storm along with it. So we've got our predominant winds, but we also have this huge jet stream kind of dragging everything along. Okay, let's go do a quick little review here. If I can find the right piece of paper over here somewhere. Mid-latitude storm intensification, advection. You got to get those cold air and the warm air mixing a little bit. You got to get a little bit of lift going on, usually frontal lifting. That vorticity spinning starts to get it to rise and increase the lift. Don't forget that we are going to be converting some of that water vapor to water droplets, and that latent heat energy release is going to increase the lift. Okay, we see that more in our tropical storms, but then that venting, and that's where that jet stream comes into play.